Hello, Calculus 1 class. It's Friday night and I'm thinking of you. I want to do some chain rule with you just to give you the opportunity to spend a few extra minutes doing some extra chain rule, but you're not in class. You're looking at this on your own. Isn't it exciting? Now, I'd love to do this with a few students, and all you do is that your hands would appear. So pop down the math department and we can make a video and stick it out there for the rest of the class to watch during the semester if you want. Anyway, so here's what we got. 3 examples of chain rule. And what we're going to do is we're going to do chain rule and we're going to ask the computer to do the derivative as well. So this software program, it's a computer algebra system called Scientific Workplace. I use this all the time. This is what I write your tests on because the textbook you use was written on this program. They use the same typesetting program. But this program has a computer algebra system. So this is the notation right here for the derivative with respect to x of 5 square root of x cubed plus 2x. Whoops, there's a funny little parenthesis I need to stick in here. It's unnecessary, but I need to close it off to match the rest. Let me stick it right there. I just noticed that. All right, there we go. Now, the problem looks balanced. Now, we're going to do it out loud. I'll do it with you. I know you're just watching. It's passive, but let's do this thing. Okay, taking the derivative. So there's a 5. I see it. It's going to start with 5 because there's a 5 out front connected by multiplication. Nothing happens to it. Sorry, I hit 2 keys at once. Then it's times that square root is a power. So it's times 1/2. Hit 2 keys at once again. Sorry. So I've got that 1/2. So that 1/2 comes down. And then the inside unchanged. So I'm gonna just copy and paste, because this program allows me to do that. It's kind of a sweet package. Nice. Close parenthesis. Now that's to the 1/2 minus 1/2 power. So I'm going to pop a negative 1/2 up there. 1/2 minus 1 power is negative 1/2. I'll write it as a fraction. Minus 1/2 of, I could have wrote it as negative 0.5, but let's write it as negative 1/2. Okay. Now that thing is times the derivative of the inside. And the derivative of the inside, whoops, I got to get down from the exponent position. There we go. Times the 3x squared plus 2. So I could rewrite this, but this is how I know I'm done. We have the square root of x cubed plus 2x. I only said the word of once. So once I take the derivative of x cubed plus 2x, which is 3x squared plus 2, once I take that derivative, I know I'm done. So this problem could be rewritten without that negative exponent by writing 5 over 2. We'll just write it all out as a fraction. I've got the 5 over the 2, but back up there with the 5, I've got the quantity 3x squared plus 2. I've got this thing. Now I'm going to do something that I bet the book does as well. And you don't have to do this, but it's what the pros do. You have a negative exponent, and it's a negative square root. So what you could do is take this is what that square root is, and rewrite it down here. That's where it's going to be. That's what x cubed plus 2x to the negative 1/2 is worth. That negative 1/2 means the exponent's in the denominator. So that should be what the computer gives us, something that looks like this. Let's see what they say. Hey computer, what? Evaluate. Here we go. So I've got the 5/2, I've got the 3x squared plus 2 on top, and I've got that square root down below. So hey, the computer says we did it right. That's worth something, I suppose. All right, same thing again. This one is sine x plus cosine x quantity squared. I'm going to take the derivative. I know how the derivative starts. Call on me. Okay, McDaniel, what is it? It's going to be 2 times the quantity, the inside unchanged. So I'm going to pop that down here. Instead of typing it, I'm copying it. It's to the 1 less power, but 2 minus 1 is 1. So I don't have to write a power up there. But now I've got to have it times the derivative of the inside. And the derivative of the inside is cosine x minus sine x. Uh-oh, I can't leave it like that. I just can't. Do you see what I see? I see cosine squared minus sine squared, which is famous. this thing is equal to 2 quantity cosine squared it's cosine squared x minus sine squared x. Now, I would give you full credit for that, but here's what the book would do, and here's what the computer's going to do. Cosine squared x minus sine squared x is famously one of the double angle formulas for cosine. I know, I must sound like the world's biggest geek. Oh, it's a double angle for cosine. I recognize that this is cosine 2x. That's what cosine squared minus sine squared is worth. If you don't believe me, try it, graphing the two of them on your calculator. But I bet that this is what the computer gives us, because the computer is also kind of programmed to do things the way that a math person would do it. So there it is, 2 cosine 2x. We did get it right. Now, if you did this in class, if you did this on a test, and you gave me just 2 cosine squared minus sine squared, 2 cosine squared x minus sine squared x, full credit. No big deal. But here's what the book answer would be. We're going to run into that, once in a while, and you just deal. You just deal with it. If you think you if you want to check your answer against the book answer, graph them both on your calculator. You'll see that you get the same curve. Then you know you're right. All right, one more. One more, and this video's already done. Hey, I didn't click anything. Stop it. All right, so let's take a look at this one. Let me get it a little higher on the screen here. All right. So this one says derivative, I've got a quantity to the third power, and inside that quantity is a cube. Oh, sorry, inside that quantity is a product. So I've got a product inside of a chain. I've got something to a power, but the something is itself a product. Well, let's see if we can figure this one out. I think I see what to do. I'm going to have that 3 come down, because it's a third power. So I'm going to have the 3. The inside unchanged, so that's just x cosine x. Whoops. X cosine x. That's going to be to the second power, because I'm taking the derivative of the outside. The inside is a product rule. So I'm going to have the derivative of x, which is 1, times cosine x, plus x times the derivative of cosine x, which is, I can write it like this, but you know what the pros would do? They would just move that minus sign, just stick it there. So that's what I'm going to do. That's going to be my minus sign, and I'll get rid of that one because it's not supposed to be a double minus, putting the last closing parenthesis on there. So it's going to be 3 x cosine x squared times the quantity cosine x minus x sine x. I don't see any obvious simplifications, even for somebody who likes trig. I don't see any way that this could be written any better. The computer might multiply everything out, but I don't know. Let's see what the computer says, because I know we did it right, but let's see what the computer says they do. Oh my goodness, it looks like we copied. And look, they put the x squared and the cosine squared, they put the squareds on there, because you could do that. If you have 2 factors squared, it's the same as the first factor squared times the second factor squared. So we got it right. The computer wrote it with fewer parentheses. You can think of it like that, which the math people do. Well, there's 3 crappy examples done for you in under 9 minutes. How great was that? We'll see you in class, guys, and maybe we should do one of these together sometime. Bye-bye.